Okay, I'm doing my independent study project for grade 11 physics, and today I'm gonna be talking about the physics of hockey. We're gonna talk a lot about a couple angles that are important, and we're gonna talk about Newton's laws, some acceleration, and just a lot of good physics stuff that's involved in hockey because there is a lot of physics that comes with hockey. Little to be known. So the first thing we're gonna talk about is what physics tells us about skatings and some of the important angles to maximize power. So when you're skating, during the push phase, like when you're pushing down, when you're skating, you're going to want to keep your foot at kind of like a 45-degree angles because this allows you for the maximum forward force to be transferred to the ice. Because a push less than 45 degrees prevents the skate from really gripping the ice, so you can't really get a good push in. And then also, if you go the other way, it's a push greater than 45 degrees angles. You kind of you push yourself too far laterally, so it's kind of limiting your power a little bit. And since 45-degree angles is a good angle because we know, based on Newton's third law, for every action there is an equal action, both equal in size and magnitude, but opposite in direction. So when we're pushing down, there's going to be the same force pushing back up to us, but opposite direction, and we want to make sure that that force is going in the exact direction that we want to maximize the speed that we can get to. And then the next thing I'm going to be talking about is kind of what happens to the food what happens when we're eating food and how that converts to energy in the game. So when we eat food, we ingest it into ourselves, creating chemical, and it's transformed into chemical energy. And then, as we're playing the game, that chemical energy is kind of turned into elastic energy, as we're bending our knees and we're skating, and we're kind of just bending our body to make ourselves go this way. But while we're playing the game, some of that energy is lost to thermal energy, and then also as we're transforming this chemical energy into, I'll go back into the thermal energy a little bit more. So some of the energy is lost to thermal energy because we're sweating, we're heating up, and so that is where some of the energy goes. And then as we're transforming into elastic energy, we use this elastic energy to turn it into kinetic energy. And so that's just us kind of moving along the ice. But a lot of that energy is actually lost from the heat energy that's lost through the friction with ice, and some of it is also lost from the sound energy from the game of hockey. As we know, it's a very loud game. The next thing we're going to be talking about is a little bit about shooting. The importance of shooting, or the importance of forward momentum when shooting. So we're going to do a little bit of a hypothetical problem. So if Crosby skated at 10 meters per second, that's his initial velocity,